Hello, we are speaking in this video about momentum and what is the momentum and other examples. So, what is the momentum? Momentum can be defined as the quantity of motion of a moving body, or by another definition, how difficult it is to make an object to stop. So, momentum can be represented by mass multiplied by velocity. So, if we have a momentum of a stationary object, it will be zero because we have the velocity in this case equals zero. And if we have a velocity and the mass for an object, then we will have momentum. And this momentum is directly proportional to mass and velocity. Any increase in velocity or mass will result in increase in the momentum. Why momentum is important in our life? It is essential concept of physics and important in collisions and impact loads calculations. And momentum is just about every activity that involves motions. In sport, momentum term is commonly used like if a team has the momentum, then it is on the move and is going to take some effort to stop. So imagine that we have these two cars with different velocities and different masses, and we want to calculate if they are going to collide with each other or will stop before collision, or if they are collide with each other, what's the damage we will get from this collision. So some examples of this momentum: imagine a truck full of goods has a large mass, and so it must slow down before a stoplight because it has a large momentum with the same velocity, and so it's very difficult to stop because of the large momentum. Another example is that if we imagine a small bullet and moving bullet, so the small bullet means small mass, moving bullet means high velocity. This will result in high momentum. If we have an example with calculations, we choose an example from Shobra textbook. Imagine that there is a wooden block that weighs 10 pounds and attached to a spring with a stiffness of 100 pounds per inch. And imagine a bullet weighing 0.5 pound and is fired at a speed of 60 feet per second towards this wooden block. And after collision, it is embedded in the block, so they move as one object. What will be the result of the motion U of t for this block? So the solution, we start to transfer the units into our units for all terms. So the moment will be divided, the weight will be divided on g, which is gravitational acceleration, to get the mass. So the mass m for the wooden block will equal 0.0259 pound dot square second square per inch, and same for m node 0.5/386, which is g, which means gravitational acceleration. And based on the conservation of momentum, we have that m multiplied by velocity for each particle before collision will equal m multiplied by velocity for each particle after collision. So before collision, we have only the bullet that moves. The other part was still. So now we have m node multiplied by v node that represents the bullet, and m that represents the wooden block, and m node that represents the bullet mass. So we can calculate u dot of zero, which means the velocity after just after collision when the bullet is embedded in the wooden block, and this will result in 34.28 inch per second. If we want to calculate the equation of motion and u of t, then we have the mass, which is the total mass of the bullet and the wooden block, and stiffness given as 100 pound per inch. From these two terms, we can calculate our natural frequency, which is equal second root of k over total mass, and this will result in 60.63 radial per second. So the initial condition, we have u of 0 equals 0. There is no movement for the block at t equals 0. And u dot of 0 will equal 34.29 as calculated here from the impact of the bullet. So the resulting motion is u of t equal u dot of 0 over omega sine omega t, which is the solution of the dynamic equation of motion. Thank you.